As the last video of the day, let's consider adding a method called get that is going to return the ith item from the list. We're going to say the front item is the 0th item, and for simplicity, to keep your code simple, it's okay to assume that whatever someone asks for actually exists. So in other words, if they ask for item 1,000,000 and the list only has 5 things, that's fine. Just, it's okay if your code crashes. So as an example, let's suppose this is our list right here. If we ask for l.get0, we should get back 5. Or if we ask for l.get1, we should get back 10. Okay? So what I'd like you to do is really sit down and think about this, and don't just skip to the answer. The best way I think to work on this is on paper, though if you want, you can also do it by looking in the lecture code repo and grabbing the file called IntList.java in the Lists1/exercises folder. And if you really insist, you can do it in your head, but that's no fun. Okay, so give it a shot. You can use recursion or iteration, but spoiler, I'm going to use recursion in my solution. So pause the video, and then I'll tell you what I did. Okay, so let's do it. We need a get method. So I'm going to call it public int get int I, and it's going to return the ith item of this list. And we'll even say it's an int list. Okay, so I want to do it recursively, which means I need a base case. What should the base case be? Now, even if you hadn't figured it out yet, maybe think about that question. So it turns out that the most natural base case has nothing to do with the tail, or the rest, I mean, or the first. Instead, it's if someone asks me for my 0th item, I should just return what? Well, I should just return the first item, right? I just give the data. That's what's at the front of the list. You ask me for 0, I return first. Now, if someone has a larger I, if I is, say, 1 or 2 or 3, then I don't have the value. Someone else does. And it's important to keep in mind that what's my value 1 is my neighbor, or my rest's value 0. Or what's my 5th value is my neighbor's 4th, neighbor's 3rd, neighbor's 2nd, neighbor's 1st, neighbor's 0th, all the way down the line, if that made some sense. So in other words, I need to ask the rest of the list for something. Rest.size, or not size, not right. I need to ask rest for something. What should I ask for? Well, I should ask not for their ith item, but their i-1th item. Now, if we try running this, we can just test it out real quick. Let's say we try running it with 0. I should get back 5. Indeed, I do. How about 2? I get back 15. Okay, 1. Oops. 1, I get back 10. And 100, I get some crash. So it looks like it worked fine. So if that didn't make total sense, what I encourage you to do is put this through the Java visualizer. I'm not going to do it here because it's actually quite similar to size, and I think it's probably a good exercise for you to jump in and try it out. But if you got it, great. And if you did it iteratively, also great. So that's it as far as what I'm going to develop in class. So at this point, you probably have the feeling that, well, while at the beginning we were just kind of lackadaisically thinking about our lives and walruses and whatever else, at some point we took off like a rocket and developed this list thing at light speed, and maybe, just maybe, it feels a little shaky. So what I'm going to encourage you to do is maybe try a couple more exercises. So if you'd like, there's these extra ungraded exercises called extra IntList practice, I'll even say .java, in the Lists1/exercises folder and the lecture code GitHub directory. So if we look at, if you go to this repository and you open this file, you'll see there are 2 methods waiting to be filled in by you. IncreList, what it does is it takes a list and it increments all of the values by the x value here. And as a constraint, whenever it's done, nothing in the list that you originally created should change. Instead, there should be a totally new list returned by this method where it has its own copies of everything. Down here, you'll write another version of this method called dinkerList. This one, you should not use the keyword new, and instead you should do all the work in place. Okay? So once you jump into this, you'll see it's a little challenging to think about what exactly, how you're going to approach this and what these 2 things mean. So give it a shot, and feel free to post on Piazza or talk to your friends and work this out. It's not for a grade, and try and figure out a solution. So that's it for today. So even though right now it may seem a little intimidating that we're flying through lists, we're going to spend a lot of time on these and get really fluent with them and become super magical list creator people. That wasn't the greatest and most rousing close, but hey, we got, 37 more to go, so I'll take it.